In trigonometry, we study the relationships between the sides and angles of triangles. We learn trigonometry because it has many practical applications in fields such as engineering, physics, astronomy, and architecture. An interesting thing about trigonometry is that even though its basic definitions, you'll see in a minute, have to do with right triangles, it turns out to be a powerful tool for modeling and analyzing many types of waves, such as sound waves, light waves, and electrical signals. As such, it helps us gain a deeper understanding of the world around us. Okay, first things first. It's important to be able to label the three sides of a right triangle as the hypotenuse, the adjacent leg, or the opposite leg. So let's get that figured out. Now, I always like to start with the hypotenuse because that's always across from the right angle. So the little box indicates that it's a right angle, and the hypotenuse is the side across from that right angle. Now, this little theta symbol here is indicating that we are using this angle here. So from the perspective of this angle, this leg over here on the other side of the triangle is the opposite leg because it's on the other side of the triangle from this angle. Now the other leg that actually forms one side of this angle is the adjacent leg. Adjacent means next to. Now, the angle that we're using doesn't always have to be down here on the bottom. Notice here, theta is this angle up here on top. Now to label the sides, notice the hypotenuse is across from the right angle, so it's good to start with that. And the opposite leg is across from the angle we're using, and the adjacent leg forms one side of that angle we're using. Right, before we get going on our trigonometry, let's practice labeling our sides. So from the perspective of the marked angle, label the location of the opposite leg, adjacent leg, and the hypotenuse. All right, in this first triangle, let's go ahead and start with the hypotenuse. That's always across from the right angle. Now here's our marked angle. So the leg that's on the other side of the triangle is the opposite leg. And the leg that forms one side of this angle is the adjacent leg. Now in this next triangle, the hypotenuse is the hypotenuse. I'm going to go ahead and abbreviate that as HYP for hypotenuse. Now from the perspective of this angle, the opposite leg is on the opposite side of the triangle. So there's our opposite leg. And the adjacent leg is right there touching the angle that we're using. On this third triangle, let's go ahead and label the hypotenuse. And then from the perspective of this angle, the opposite leg is on the other side of the triangle. And from this angle, the adjacent leg is one right next to that angle. Okay, let's learn these three definitions. Let's figure out what the sine, cosine, and tangent of an angle are. The sine of an angle is going to equal a fraction or a ratio. It is the length of the opposite leg over the hypotenuse. Now the cosine of an angle is the length of the adjacent leg over the hypotenuse. And the tangent of an angle is the length of the opposite leg over the length of the adjacent leg. So we see here that even though sine, cosine, and tangent have mysterious names, they just equal fractions. All right, let's practice using those fractions. So we're going to find the value of each trigonometric ratio. these ratios are going to look like fractions. If necessary, round to 3 decimal places. All right, the definition of the sine of an angle is it's equal to the length of the opposite leg over the hypotenuse. All right, so down here in our triangle, now it's telling us to use the angle x. So here's the angle we're using. Now the hypotenuse is always the hypotenuse. The opposite leg is the leg on the opposite side of the triangle. The adjacent leg from this angle is the leg that's right next to that angle. Now, since sine is opposite over hypotenuse, we are not interested in the adjacent leg in this case. We want the opposite leg, which is 30, over the hypotenuse, which is 50. And we're going to write this as a decimal. And 30 divided by 50 equals 0.6. All right, the cosine of an angle, in this case we're using angle z, will be the adjacent leg over the hypotenuse. All right, so down here in the triangle, the hypotenuse is always across from the right angle. So the 50 is the hypotenuse. We're using angle z. So from the perspective of angle z, the 48 is on the opposite side of the triangle. So that's the opposite leg. And the 14 is right next to that angle, so that's adjacent. Notice I always start with the hypotenuse because that one is always across from the right angle, so then we don't get it mixed up with one of the other legs. Right, so in this case, the adjacent leg has a length of 14, and the hypotenuse has a length of 50. And 14 divided by 50 equals 0.28. And the tangent of an angle, that equals the length of the opposite leg over the length of the adjacent leg. Let's label our triangle. Start with the hypotenuse, so 34 is the hypotenuse. It's across from the right angle. Now we're using angle z, because they're telling us to use angle z. And the opposite leg is on the opposite side, so that'll be the 30. And the adjacent leg is next to the angle we're using. Now the tangent uses opposite and adjacent. It does not use the hypotenuse. So we're not going to be using the 34. All right, so we have opposite over adjacent. I'll write it down here. So that'll be 30 over 16. And dividing 30 by 16, we get 1.875. Right, one challenge when doing trigonometry is remembering which one to use. When do we use sine? When do we use cosine? When do we use tangent? Well, fortunately, we have a way to remember that, and that's with SOHCAHTOA. Now, to have this help, we have to remember how to spell it. And that's because it tells us that, well, the sine of an angle equals the opposite over hypotenuse. And the ka, well, that tells us that the cosine is adjacent over hypotenuse. And the tangent of an angle, well, that's equal to the opposite leg over the adjacent leg. Now, SOHCAHTOA is not anything official mathematically. It's just a convenient way to remember which is sine, which is cosine, which is tangent. So once again, sine is opposite over hypotenuse. cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So I encourage you to use SOHCAHTOA, just remember how to spell it, to help you remember when to use sine, when to use cosine, and when to use tangent. Okay, let's find the sine of angle t, cosine of angle t, and tangent of angle t if t is the marked angle. So in other words, t is this angle right here that's marked. Okay, let's write down our little tool to help us remember which one is which. SOHCAHTOA. And from angle t, let's label our diagram here, starting with the hypotenuse. That's always across some right angle. The hypotenuse is the hypotenuse. And from the perspective of angle t, the 12 is the opposite leg because it's on the opposite side. And the t is the adjacent leg. Okay, so the sine of angle t equals opposite over hypotenuse. So that's 12 over 15.62. And when we divide that, we get 0.768. All right, the cosine of angle t, well, that equals adjacent over hypotenuse. So that'll be 10 over 15.62. And when we divide that, we get 0.640. And the tangent of angle t, well, tangent is opposite over adjacent, so that's 12 over 10. And when we divide those, we get 1.2. Now, there's a little bit more here. We have special names for the reciprocals of these fractions. So if the sine of an angle is opposite over hypotenuse, the cosecant of that angle equals the reciprocal of this sine fraction. It's hypotenuse over opposite. And if the cosine of an angle is adjacent over hypotenuse, the secant of that angle is hypotenuse over adjacent, the reciprocal of that fraction. And same thing with cotangent. So we have cosecant, secant, and cotangent, the reciprocals of sine, cosine, and tangent. Now, one thing, notice that cosecant is the reciprocal of sine. And secant is the reciprocal of cosine. It's a little confusing because the first letters don't match up. But then the cotangent, that one is easy to remember. Okay, so last example, let's find the secant, cosecant, and cotangent of angle t if t is this right angle. Now, I accidentally chose a bad example here because both legs are 12. So to better exemplify how this works, let's change this 12 into a 13. Just to make this a more useful example. Okay, the secant of an angle, well, that's the reciprocal of cosine. So this is going to be hypotenuse over adjacent. So if we remember our SOHCAHTOA, remember secant matches up with cosine. So that's why it's the reciprocal of adjacent over hypotenuse. Okay, so that'll be 16.97, the hypotenuse. And we haven't labeled our triangle yet, so let's do that. The hypotenuse is the hypotenuse. From angle T, the 13 is the opposite leg. And from angle T, the 12 is the adjacent leg. So we want that 12. When we divide those, we get 1.414. Now the cosecant of angle T, let's see, cosecant will be the reciprocal of sine. So we want hypotenuse over opposite. So that will be 16.97 over 13. Actually, change the 12 into a 13 on this example. So we ended up 1.305. And then finally, the cotangent of angle T. Instead of opposite over adjacent, cotangent is the reciprocal of that, so that will be adjacent over opposite, which is just 12 over 13. When we divide that, we get 0.923. Okay, hopefully this introduction to trigonometry has been helpful. This is Mr. Ela, signing off.